What is up, everyone? Welcome to another session. What are we going to be talking about tonight? We're going to get in some demand cooling and refrigerant injection. Something very, very important to understand. It doesn't matter where you're at in the world, refrigeration regulations are changing. They have been changing for years. If you're in Europe, they're the most stringent. If you're in North America, they're starting to change. If you're in Australia, they're starting to change as well. So a lot of here in Canada, where I'm at, since 2016, so almost 10 years now, they've been doing retrofits from 404 and R22 for 448, 449. Back in the 80s, back in the 90s and the early 2000s, when I worked in supermarket in the field on the tools, I worked on tons of low temp R22. And on all of those R22 systems, it had low temp systems. It had a fan on the top, and it had one of these demand cooling modules because I worked. There was a lot of Copeland in Canada at the time. It was dominating Western Canada for sure. I've seen some Bitzers. There's way more out there now on Bitzers than it was back when I was working on the racks that I was working on. I worked on a lot of different ones, but we always had this demand cooling. I didn't really know what it was. So I was told, okay, well, because it gets warmer, the discharge, a high compression ratio, we need to inject some refrigerant in it to cool it down so it doesn't burn out the oil. But it didn't matter. I've seen so many R22 low temp compressors looked in the site class. It could be a Carlisle even, could have been a Copeland. It's brown and black in there just because it was running too hot. These compressors were just running too hot. So then 404 started to come into the industry, and 404 does not run as hot as R22. So all of a sudden on low temps, you didn't need demand cooling anymore. You could get away with just head cooling fan. Jonathan, what's up, brother? Good to see you, man. It's been a while. But the thing is that all of a sudden we're going from 404 now to 448, 449. And well, this is even 10 years ago. That's what was going on. So they went to 448, 449. Now 448, 449 run hotter. The characteristics of the refrigerant run hotter than 404, but not as hot as R22. So depending on the application, depending on the operation envelope of that compressor, you may have to add demand cooling or not. So I get people that message me on Facebook all the time. It's like, hey, Trevor, I'm doing this retrofit. I'm adding this and that. Do I need to add demand cooling? If it's a low temp application, I just say yes. You know, if you need to pinch pennies and stuff, you know what I mean? You got to go in, and I'm going to show you tonight how to figure that out. Do you need demand cooling or not? Do you need refrigerant injection or not? Could you get away with a head cooling fan? It all depends. It all depends on that operation envelope. What is your SCT or SDT, saturated condensing temperature or saturated discharge temperature? And what is your saturated suction temperature, SST? What is that evaporator running at? What is that condenser running at? And that's going to tell you. So that's the design conditions. And then when the lower you go in your temperature means lower pressure, means lower mass flow. So less gas is moving because we need all these compressors are refrigerant cool. We need that mass to come and cool the motor down because the motor generates a lot of heat. That mass flow starts to slow down. So we're not getting enough cooling. So now that increases the temperature. So now that risks what? It risks our oil from starting to lose lubrication and potentially starting to break down. So this is why we see what Copeland calls their brand demand cooling, refrigerant injection. The other manufacturers call it, when you get onto a scroll, they call it EVI for Copeland. We'll dive into a lot of that stuff. How many of you here tonight, let's see a show like a thumbs up or in the chat, if you've worked on a compressor that has refrigerant injection or demand cooling? Just shoot it in the chat. I would love to see. So Aiden has, great job, Aiden. That does not surprise me. You've been working on everything, brother. Who else? Let's see. One person from all this. That's a lot of you on here tonight. One person. Okay. Well, we're going to learn. David, that a boy. Keith, some. Great. Okay. Now look, we're starting to loosen up. There we go. Chance. Nice. Nice. And if you haven't, that's okay. Be honest with yourself. This is one of the biggest things. I'm doing a CO2 course today with a great group, 6-week CO2, intro to CO2. And what I want to know, like from everyone, is just be honest with yourself. If you don't know something, just say you don't know. Joel, great. Jason, awesome. Nabil, just tell them. Don't. I know it's hard because I know when I was younger, and I think back, 15, 20 years ago when I was in industry, I didn't want to tell my boss I didn't know something because I wanted to look like I knew what I was doing all the time. But realistically, even though I went to school, I went to 4-year apprenticeship program. When I finished, I didn't know as much as I should have known because I wasn't working on the same stuff day in and out. I was working on boilers sometimes, racks some other times, condensing units sometimes, doing construction. So it wasn't like I was focused on supermarket service when I started. Benny, thank you very much for being honest. So what I would have liked to do a little bit better has been more honest with myself and ask more of those what people would call simple questions. You know what I mean? Or questions people are like, oh, don't ask a stupid question. There's no stupid question in refrigeration. Refrigeration is all facts. So it doesn't matter what anyone says to me. Refrigeration is facts. It's thermodynamics. It's numbers. Okay. Same with voltage. Same thing. So we got to get the numbers. When we get the numbers, we can troubleshoot anything. This is what I told the class today too. It's like, if you know how every component works, every component that's on that system, and how that system sequence operation is supposed to run, you can troubleshoot anything. Because it doesn't matter if it's a little fridge or a big industrial system with screw compressors on it. Refrigeration is still the same. We just get intimidated on it. I see the technicians that work on racks. You can't put them go work on a self-contained. Same thing, guy working on a self-contained can't just go out work on a rack. You need a little bit of experience. And all it is, it's the same thing. We have a compressor moving refrigerant around, absorbing heat, rejecting heat, absorbing heat, rejecting heat. Same thing. So let's make it simple on ourselves. And that's one of the things that I think I faulted myself on when I first started out. I was thinking, refrigeration is this big animal. Well, there's lots to it for sure. Does it take time? Yeah. But it takes long time to be a doctor or a lawyer or a police officer or a fireman. You know what I mean? It takes time to be experienced in all that stuff as well. Okay. This is where it is. This is where you're going to start to learn. How many people have seen an operation envelope like this? Let's see a thumbs up or say yeah in the chat. Because right here, I got two operation envelope, one from a Bitzer compressor from their Bitzer software, and I'm going to show you how to get into that. And the other one's out of a Copeland manual. Okay, the Copeland. This one's the North American Copeland manual. I will show you how to get to the European Copeland manual because you need, depending on where you're at in the world, you might be getting European compressor, you might get U.S. compressor. One thing about the Bitzer, they standardize on a lot of their documentation and on their compressors. Where for Copeland, it's the U.S. will have different manuals for their compressors versus Europe. But you know what? I read both of them. Both of them. It makes it so much better just reading both of them because they all have great points. I do tend to go to the European ones first, even to find some deeper information. I find they've been a bit more detailed in their technical documents, and I'll show you that. Okay, so this is an operation envelope. The black lines that's where the maximum the Bitzer compressor can run. Okay, same over here on this. Let me get the laser pointer up. This here, and this is the operation envelope of a Copeland. Depending on the model number, it's going to change. So they're doing a more of a rough idea. But this is a specific model number because I threw this into the Bitzer software, which I'll show you how to do. If I was running anywhere here, I do not need any additional cooling. Okay, don't need any additional cooling. But look, I'm running up here. And if you're running up here or even up here, which is even worse, because as we move down, we drop that suction temperature, we drop that suction pressure. That means we got what? Less what? We got less mass flow. So we got less of that nice cool gas coming back. Even though it's minus 40, we just don't have enough coming back. So that's why we have additional cooling or suction gas superheat, additional cooling and specific suction gas superheat. So less than 20K, which is 36 degrees Fahrenheit. It doesn't matter the units, you just want to understand that. Okay. And if we look over here, so that's kind of the Bitzer one. So right now this one here is we're at about 45 SCT or SDT, and we're minus 30 SST. Okay. So that's Celsius. So we go over to the demand cooling for the Copeland one. You'll see the example. Here's the refrigerant. I forgot to say, I think I did 454C for this one. This is 407 AFHC or 448449. This says head cooling fan required, so a head fan required, but a core sense discharge temperature protection. So on back in 2013, I think, maybe it was 2010, I can't remember exact dates. That's when they came out and they launched the core sense product line like 15 years ago. And 10, 15 years, well, over 10, because I worked for them almost 10 years ago. So yeah. So before I started, so the big thing is that the core sense has the motor overload protector in it. So instead of having that the INT69 or the Crewan module, like all the manufacturers were using at one time, they built their own. So if you had that temperature probe in there, you only need to use a head cooling fan, so it would trip off the compressor. So it would node you because you're running hotter. And that's on these. The demand cooling would not be active. For instance, minus 25 evaporating, 80 Fahrenheit condensing, 65 return gas temperature. There would not be any injection. So that's over on this side. So if you have demand cooling, or you don't have that core sense on it, for an example, you don't have that, you got to go with demand cooling. Okay. If you're down below here, on this operation envelope, so below this demand cooling injection line, it wouldn't be injection. But if we're running up here, we would be injecting. So this is in Fahrenheit now. So we'll do 120 Fahrenheit and minus 20. That would be injecting, because we got to cool that stuff down. Okay. Going back over to this one, if it just has a head cooling fan, you can see it says a maximum of 40 degrees compressor return gas temperature. So if you're in this zone, if you drop it down, you're in this zone, a maximum of 20 degrees Fahrenheit compressor superheat, which is like 9K or something like that, Kelvin. I work in refrigerant transport with open compressors, and it's common to see 52 Celsius TC, and a maximum can be lowered. The TE minus 25C and works perfectly without liquid or injection. Excellent. So that's fine. You just want to make sure that that oil doesn't get too hot. What is that discharge temperature? You got to be monitoring that. What type of compressor are you using? Are you using open drive compressor versus a semi-hermetic or a scroll compressor, right? So there's a lot of differences in that. So depending on the compressor design. So thank you for letting us know, Hector, on that. Okay, let's dive a little bit into this demand cooling module, what it is. Honestly, you got a controller. This controller has a sensor on it. Okay, the sensor goes into the head of the compressor or into the body of the compressor, depending on the design. Because if it's a 3-cylinder compressor, 4-cylinder compressor, or 6-cylinder compressor, it's going to be different. Okay, and then you have an injection valve, which you need to take from your liquid line. So you have liquid refrigerant come from your liquid line. You have a T, and that liquid's going all around. Hopefully, you have a sight glass and inline filter. A lot of times you don't. You don't have a manual shut off, and then you have the injection valve. Okay, so this injection valve would open. Okay, all of a sudden the temperature starts getting up 290 degrees Fahrenheit, 300 degrees, around 140 Celsius. All of a sudden that's injecting, that's wide open. 130 Celsius probably starts to open. 140, it'll be wide open because you're just too hot. We need to get the cooling in there because we're going to start killing that oil, cooking that compressor. We dive in a little bit deeper. This is kind of what the module looks like when it's open. This is from Refrigerant Confidential. If you haven't checked out any of his YouTube videos, go check it out. You got a lot of good troubleshooting ones there. So here's the module power. So this is the powered up. So you need power to that. This is the solenoid. So if you look right over here on the wiring diagram, there's a solenoid, there's your M, there's your LMAS, L1, L2. So L1, L2 down here, my sensor is right here. Then I got M, L, and A. M, L, and A. Okay, just remember, this is always always follow the manual when you're wiring it up. That's what I meant to say. You have a sensor right here. So this sensor will go into the head of the compressor. And what will happen is as that sensor starts to rise up in temperature, the resistance starts to change. That resistance will send a signal in here to close this switch. And when that switch closes inside the demand cooling, it's going to say, we need some cooling. It's going to open up the solenoid and inject it in it. Okay. There's different ways to wire them up too, because you might have a syntronic, you might have other controls. Right here, actually, we've got a syntronic. If it has a core sense diagnostic, it's going to be a different wiring scheme. If you have a digital compressor as well on top of it, you're going to want to look at that wiring scheme, because they all have discharge temperature sensors, and you can't have them all running because they'll fight each other. So just dive into those manuals. So here's your power. Here's the sensor, the little temperature sensor down the bottom there of the module. And then that's where your safety switches and your alarm. This is kind of what it looks like. Diving a little bit deeper in there. As you start to rise up, the temperature starts to rise, and you get up to 292 Fahrenheit. I think that's around 130 Celsius. You start to get up around to that temperature. That center is in the compressor, in the head of the compressor, and I'll show you where it looks right in the head, because the hottest part of any compressor is right at that the discharge valves. And when those discharge, that last squish of gas right up there, that's the hottest part of any compressor. Okay, and when the temperature rises up high enough, it says solenoid on. And look, we see in here it says at 2100 ohms. That solenoid valve is on. So open up. As the temperature starts to drop, it gets cooler. The ohms start to go up. So temperature down, ohms go up. NTC, resistor. Oh, solenoid's off. Okay. And then you got to test this stuff. This is no different than any temperature sensor out there. You got to test it. This one here, you use resistance. There's some that you use voltage. It all depends on the type of, that's a pressure transducer. I was thinking of something else. But use your ohm it out at room temperature, 77 Fahrenheit, 25 Celsius, should be about 90,000 ohms. Super important to look in these manuals. Oh, here's the core sense module. I put this one in here too. This is kind of what the Parker model injection valve looks like. There's lots of different ones. Alco used to have them. Parker has injection valves. You want to make sure you get the right one. You can't just throw any solenoid on there. I'm going through this. Alarm activates when the TC sensors reach 1700 ohms. So 310 degrees Fahrenheit. That's around, I think, 150 Celsius, 150, 51 or 52 Celsius. That's alarms energized. And what will happen at that point is it'll switch from M, which is powering your contactor, which goes through your core sense and then energizes your contactor for your compressor. It'll go to alarm. So now I don't have power going through, and the compressor is going to shut off, and it's going to trip on your demand cooling alarm. On discharge / condenser temp, how would you estimate if you need injection on a system that is not operational yet? Is it similar to what my highest design temp is? Oh, that's a great question. So what you need to do is you need to go into the compressor software, and I can show you how to do that. As long as you know your design conditions, you can figure out if it's going to be injecting or not. Now, if your condenser gets plugged, or your water tower is not working properly, you don't have the proper flow, whatever it is, that won't be taken into account. But yes, you can do that before you can find that out. And that was kind of from the operation envelopes. And I'll show you that, Tom, in a minute here. Okay, let's keep going. And then here's the resistance chart. So this is kind of one of the resistors that you would screw into the head of the compressor. You would need to put some either nylog on there or some thermal paste to put on there, which is really good. And then here's the sensor resistance. So at 90,000, or so at 90,000 right here, 77 Fahrenheit or 25 degrees Celsius. I'm not going to get into liquid injection yet on scrolls, but we'll talk about that in a few minutes here. Let me see what's going on. Let me kill this for a second. We got a lot on the go here, so I got too many things up. Let me see. Yeah, this is the one here. Okay, let's dive in how to find this stuff. So the first thing is let's do Bitzer. Bitzer.d/web software. Good friends at Bitzer there. What you want to do is you can go down to if you're doing CO2 systems. This works great on your phone. They didn't have the app they had was not very good, but now they made it a mobile version. This is great. Honestly, if you need to change your to imperial or to metric, you can do it right down here. We'll do this one in metric. It doesn't matter to me. It's just units. That's all it is. You just take out a calculator and you go to units plus, which I work. And like, if I don't understand, I don't know what it needs to be in Fahrenheit or Celsius or bar or PSI or kilopascals, it just kilowatts versus BTUs. It doesn't matter. That shouldn't stop you from being an awesome technician. It's only units. Okay, so let's dive into something here. We'll just do old school R22. There's lots of those compressors still out there in the field. Let's go minus 35 Celsius, right? Let's do minus 40 Celsius because it's minus 40 Fahrenheit at the same time. So it makes it easier for everyone. You press this little, let's pick a compressor model. So let's just randomly pick one. Let's do this one, a 4 VE10. And let's hit the plus button up here and see what happens. Oh, look, it tells you that I can't use this compressor at a minus 40 application. So we got to do a minus 30 application. We hit plus again and see what happens. Oh, well, now our maximum condensing can only be 44 Celsius. Okay, so we go down to our SDT. We change that to 44 and we hit the plus button again because we're outside the envelope of that compressor. Boom, look at this. Here's where the information is. This is it. Like, I did not know this stuff. And it was these softwares weren't even out at that time. They had the old books. Like, I remember Copeland manuals that were like gold for people that I was with, all the old school guys. They had all the electrical manuals. So this is it. So when we hit limits, so this is the results. This is all the capacities they can do. But if we go to limits, this is where it shows you that operation envelope. Look at where we're at in this operation envelope. We're at the very far left and very top of that operation envelope, maxing out that compressor. Okay, so what this really means is that we got a really low amount of flow. So I think if we do one of these, I can't remember which one it is. It's been a while since I opened these ones. Export. No, I think it might be that one there, but you can go to technical data. It explains this is what the maximum operation current is. When you get in here, there's a lot of good information in here. And what does that mean? Maximum operation current. Well, that's the max that compressor will run before the internal overload will trip. So if this compressor is, say, running at 22 amps, it's going to trip off on its internal overloads. And then it'll talk about the different options down here. So I don't see, it just says additional fan. So if we go to accessories, this is where it's going to come in. So what do we need? We need a discharge temperature probe. And right here it says this module. Let's say doesn't even have refrigerant injection on this one. So this compressor can go without refrigerant injection. You just need a additional fan for this compressor. That is impressive. Sometimes there's a water-cooled head. And so when you get in here, here's where all the different information is. So let me try a different refrigerant. Let's go to 454C. It's a newer refrigerant. Same compressor, same everything else, minus 30. Let's see, minus 30 works. Let's go to minus 40 again. Minus 40. Let's see if this compressor will work at minus 40. No, it does not. Oh, it does, but we need a 43-degree maxing condenser. You're like, well, why do I even care about this stuff? If you start to put this information in on all the systems you're working on and servicing, and you can really get an understanding exactly what's happening inside that compressor. Let's go to the limits. The same thing will be happening way up here. This one for sure should have liquid injection or refrigerant injection as an option. And it definitely doesn't. It just has additional fans on this one as well. That's impressive. Sometimes you would see, it would say down here, it doesn't have the manual. Usually it'll have the manual for, which one did I do earlier tonight? Let's just check that out. Let's go to 448, 449, I think it was. Maybe it's a different compressor too, because different compressors will yield different results. Once again, accessories. And all these will just need an additional fan, which is great. Okay, I found the technical document. So this is the technical document. All I did was search Bitzer refrigerant injection module, and it's the BMT liquid injection module. This here explains how you do it. So if you had to, for an example, and someone asked me the question, would I use liquid injection? If I'm running my compressor right up here, select operation mode RI. So that's refrigerant injection. So right here, this compressor could go, and I didn't point that out first. If I'm running anywhere out here, I can go lower than that minus 40. I can go down to, what did it just say here? Minus 45 with the RI module. So let me do minus 45. Let's see, it should come up this time. Let's go to results, minus 45, accessories. There, oh no, it still didn't come up. Okay, not sure why. Minus 45, 40, it's still staying right there. But as you can, hopefully you can see that minus 45 and 42 Celsius. I really don't know why it's not moving that over anymore. Oh, there we go. Now I think I just moved it myself. I didn't know. That's new to me. Like that's an update where you can click on it and move your little dot so it moves and change the temperatures. And hopefully it puts that option on there. It still doesn't. Okay. Increase the condenser temperature. Yeah, well, let's do that. Thank you. No, it won't work with that. I think it was 45. It said the highest, but either way, let's see. It still won't even work. 43. I'm not sure why it doesn't pop up. I'll double check with Bitzer. I'll ask them why that doesn't come up, because earlier tonight when I did it, or today, it worked. But either way, if I was running that compressor and that minus 40 like that high compression ratio, I'd probably consider putting an injection. And what you have to do to tell, what's your telltale sign? Does anybody know? If you're running those conditions, what you would do? Check the discharge temperature. 4 inches when it's running in the middle of the day, working its hardest, the highest load, have your discharge temperature, bro, and monitor that. That's going to tell you there if you need injection or not, or a head cooling fan, something to cool down that motor. And the way it works, you always want to get into the manuals and dive in and look how it works. So here's our L1, L2, L3. So this is our power coming in. We got control box, so it's showing a transformer here, but here's the controls: low pressure, high pressure control. You got your OLC, so that's your optical sensor, or your delta pi. This is your pressure sensor. Doesn't matter which one it is. Then you have your refrigerant injection module. This is the BMT for this design. Okay, and then you got the INT. This is your motor overload. And then this is your INT 80 oil control solenoid. So this is the oil level control. and this is your motor overload. And Calvin, yeah, maybe it is the motor 2. Maybe if I select the motor 2, it probably would have worked. And how does this work? So here's your contacts to start your compressor. If I have refrigerant going through here, power going through here, power going through here, the solenoid's activated. When this discharge sensor, because this will be up, this one will go across here. This is your alarm right here. So this is normally, any electrical circuit is always in the off position. So if this is energized, this will be up. This will go across here. This is energized. This will be up. That'll be closed. And this, though, will only close to open your solenoid when your discharge temperature hits a certain temperature. And if we scroll down, can't remember where it's at. I think it's 130 Celsius. Let's just throw it back. Sorry. So 250 Fahrenheit, which is about, I would say, probably that temperature, around 130. We'll have to double check here. If anyone knows, just throw it in chat. But I think it's around that 130. So nobody knows right off the top of their head. Unbelievable. Oh, sorry, 121. So at 121, that'll open up Celsius, or 235 when it shuts off, which is about 110, 112 Celsius. Pretty straightforward. Got a question here. Why would you want to go do liquid injection versus two-stage compressor or a higher differential compressor that can handle it without injecting? So there's different reasons for that. You can't always get a two-stage compressor for certain refrigerants. Not all manufacturers have two-stage compressors. Bitzer has a two-stage compressor, but it's not for all applications. And that's a great question. That is a great question. I don't have an answer for you. Price could be the costs. But I'd love for you to find out and email me what you found out, because I don't dive into it. There are two-stage compressors on the market, but I don't see them. Only when you're going down to like minus 60, minus 70, that's when you go to two-stage. When you're running minus 30 or minus 40, I don't think I've seen two-stage. Not many anyway that I can think of. Okay, so just say we want to dive into what Copeland has. So all you have to do is go, all I did on Google was write Copeland demand cooling, and the first link is the North American one. I'm sure if you're in Australia or if you're in Europe, the European one will pop up. But what I showed you earlier is just right out of this manual. So you go down. This is kind of what it looks like. I'll zoom in a bit. That's what it looks like on a 3-cylinder compressor. But on a 4-cylinder and a 6-cylinder compressor, it's going to look different. Kind of like when I go to the Bitzer one right here. So if I zoom out a little bit, you see this is a 6-cylinder. Do you see how it's piped? You got to have two different injection valves and two different temperature probes. And right here, it'll show you where the injection nozzle goes. And sometimes you have a second injection nozzle on the Bitzer one. So right here on the side, on this side right here, there a nozzle would be there, and then a nozzle on this side for that injection. Okay, so here's the operation envelope, and it dives in. I'm not going to go through this. It shows you where to put the probe and where it's going to inject at. You guys can read this, and you should take your time, learn this stuff, get better, because when you're out there and troubleshooting, one of the things that you have to do is when you're servicing a compressor, you're doing a maintenance, you drop the oil out. Just say you have to do an oil change. Pull this sensor out and clean it. It's going to be dirty. There's going to be carbon on it. Clean it out. Take a Scotch brush and just clean it off, and then put it back in. I've seen these bend before quite easily. You have to have a full column of liquid. I think in Copeland manual, they say 5 degrees subcooling, 2 or 3K subcooling coming in. Maybe that's the liquid injection. No, that's the DTC valve, not for these ones. But either way, you got to have a full column of liquid going into them. And then now if you want to find out the European one, so I'll go to Copeland and show you how to do it. Copeland.com. So if you're in the US, you go to products, you go to refrigeration, you go to Copeland, and then what you want to do is go to compressors. They got a ton of different stuff. So is it scrolling down? Yeah, you scroll down. If it's semi-hermetics or scrolls, always refrigeration. You will start to see, though, injection on and vapor injection on heat pump compressors. So their new Y model compressors under scrolls, they're a big compressor. But if you're going into 4 and 6D technology, you click on the product, and then there's going to be a documents page. And you just click on documents, and it'll take you all the way down. And then I don't know I can't remember if it's in data sheets, manuals and guides. No, it doesn't even have it in here. So you got to go to AE bulletins. So they just have the replacement guide. So that's pretty useless. So if you go back to Copeland, you go to online, right here, online OPI tool, online product information. You go to bulletins. You can search it right here. You go into bulletins. You go into US AE bulletins. Oh, no, that's where you get all their old manuals. Application engineering. And then you go into, which one it is, not capacity control. It's been a little bit. Maybe it's under here. No, it's not there. Let's go. It's probably just under compressors. Been a while since I've been here in here. You have to do compressors, semi-hermetic compressors. And then that's discus 2, discus 3. Demand cooling right here, discus demand cooling. And that's the one that I think we just pulled up earlier. There is one for, no, there's actually not one for the 6D model. They don't show it. You got to get the guide out of the instruction manual. But this is where you would find all those manuals. I think there's another one here somewhere. Cooling requirements for Copeland. So here's the other one. So look, they updated it in the 22nd, which is great. And then if we go down, maybe it has no, it just has the model numbers of it. And then the different types of, this is the oil loop. So just a little bit about cooling, but it doesn't talk about it there. So anyway, if you want to go to the European, so if you got European Copeland compressor, you got to go up here, you want to change it, and you just want to go to the UK. This is the easiest way to do it, because you could be in a different country. Like I'm in Canada, I'd never use the Canada site because it's not helpful at all. So right here you go to products, refrigeration, same thing. You find Copeland compressors, you go down, you go HFC, HFO compressor. You could do CO2, it doesn't even matter either. Pick the compressors you want. Okay, Copeland with stream, view product. This is the one where they do have a manual section as well, but I go to documents and drawings for that specific compressor, manuals and guides. And then right here for this compressor, these guides are pretty cool. You scroll down and you look for liquid injection, I think it is, demand cooling right here. You click on that and then it'll talk about it. But the funny thing is there's so many different manuals. I read this one, you got to go all the way to the bottom. And then it tells you somewhere down at the bottom that you got to read a different manual. Where was it at? So here's a tip for you. Control F, liquid injection. You write in there. Control F on any PDF document, even on your phone. It's the 3 dots on your phone. Find on this page. You write in whatever you want to write, and if it's on that page. So there's 11. So I was going like this through it to find right here. Look, if we want to learn more about liquid injection, we got to go to this manual here, a different start guide. So if we go back to here, and I'm pretty sure, I thought I just found data and bulletins, and one of these say liquid injection. So right here, look at this one, liquid injection. So you click on it, and this is the mod. Oh no, this is not the right one. That's the module. So there's a lot to it. There's a lot to it to find all this stuff. I think it's right here. Where's the liquid? Oh, right here, demand cooling, liquid injection. I just went to the controller. So right here, it'll talk about the temperature probe, where to put it in. Do you see how it gives you all the breakdown for the different configurations for injections for the 6M, 4M? And this stuff's not easy, guys. Like I spend almost a decade at this company, not that long, 7 years, 8 years at this company. And I've read a lot of these manuals, and still there's so much that is out there, but you got to take the time to find this stuff and see. It shows you exactly step by step on how to do it. And other compressor, like you could go to if it's Carlisle, same thing. You go into the Carwin software, you get in there, and then you go into their guides and look up their guides to find out. You go to their guides to find out how it works. How it works. I'd love to see if you have any questions. I do actually want to show you a few other things. I'm not sure if a lot of you know, but I have a supermarket academy now, which is rocking right now. So it's a 4-level academy, which we're diving in, showing you short videos on how to work on supermarket refrigeration, step by step. Really the fundamentals, videos on how to troubleshoot stuff. And I think it's important to learn, continue to learn, because you're here tonight, which is amazing. You're all 37 of you still here, just learning and absorbing, which is very, very important. But continuing to grow and learn. So whatever you learned here tonight, if you did learn anything, share it with someone at your work. Share it with someone on your team, even if it's looking up in the Bitzer software, going into the Copeland software. It's so important to do that and take your time to continue to learn that stuff. Because if you don't, it's just going to take you longer to learn. Honestly, you spend the time now, it's going to pay off down the road, and it's really going to help you out. What else? What screen am I showing? Oh, I'm still showing this screen. Okay. So this is kind of what it looks like. We dive in, a lot of different module there. So if you know someone who wants to level up in their supermarket game, we dive into P&IDs. It's like even today, I was doing the training today, and I've trained thousands and thousands of technicians. And I didn't know what a P&ID was, piping and instrumentation drawing, before I started working for a manufacturer. I've seen them, didn't understand the value of them. Well, what's that? How does that help me troubleshoot? It's the map of a system. You match that up with the electrical diagram. I tell this everyone, I'm training people now, and I'm teaching them how to read both together. They're like night and day technicians now, night and day, because they know where to go, what to look for, understand the whole system. We think it's complex, but there's maps to super. So we dive into all that. Then we get into a ton of different stuff in the academy, just diving into EVs and sequence of operations. And then we got level 1 out right now. So I'll throw this in the chat if anybody's interested, or if you know anybody interested. I'm going to just throw the academy in the chat here so you guys can take a look at that. But if you want to level up, this is it. Doing stuff like this will get you better and grow. There's a lot of other things we have coming up too as well. We got CO2 experts. I'll show you that. Let's go to my link tree to kind of give you an idea of what's going on right now. And if you have any questions, put it in a chat, because I'll try to answer as many as I can, because I know there's quite a few of you on here. If it's about compressors, troubleshooting, refrigeration in general, I'll do my best to answer it. Because there is, like I said, there is a lot going on in refrigeration world right now, which I love to see.
And I run into a lot of electrical issues, and I'm getting kind of tired of zapping myself. Do you have any do you have any idea what I should be doing when I run into those issues?
Okay, thank you for being honest about that. So the first thing is you got to make sure your meter is working correctly. You got to make sure you test your meter and it's reading accurately. Secondly, do not rely on someone else telling you breakers are off or disconnects off. You got to verify every time. So think about at your house. You're going to work on your bathroom exhaust fan. Okay. Don't just go and just shut off the switch and then go and start playing with it. Go and shut the breaker off. Okay. So you don't accidentally hit it and you're holding the wires and you shock yourself. I always used electrical pin, not a pen. So I'd go up and I'd go and check the wire, see if it lights up or not. Then I would verify with my meter every time. Okay. Verify across them and then the ground. Ground is your friend. Ground is safety. Ground is not troubleshooting your system. Okay. Before you touch the wires with your fingers, you go to ground, and that'll tell you if there's power to those wires. Hopefully that helps. Okay. And if you want to get better, honestly, at electrical, go onto YouTube and start looking. And I said this last session is go look at some YouTube videos on DC voltage. How do you work on working on cars?
So I'm a big fan of that electric channel. Electro Boom is the name of that YouTube channel. He does some comedy stuff as well as informational stuff. It's pretty good mix.
Yeah. So just definitely work on that. Like, you should not be shocking yourself. It'll take a toll on you. And it can kill you, right? So be safe out there. You have to be safe, okay? So here's the link tree. I'm going to throw this. This is where I told you guys earlier where I put all my trainings. I think I just threw it in there. Oh, that was direct to, I was supposed to throw this to everyone. So check in the chat there. There it is there. I send this to, and here's the Supermarket Academy. I send it to one person because it was a direct copy link. Control V. There's a Supermarket Academy link tree. So you just click on it, like CO2 Expert Live right here. This is going on. This is happening. You want to learn, you want to grow. I've got the top experts. Today we dove into oil management, design, troubleshooting, oil design. If you weren't there, you missed a great session diving into that. Biggest causes of flooding on an EXV system? Question. Well, that could be one of many things. What causes flooding on a TX valve system? Same thing on an EEV. Exact same thing. Temperature probe, pressure probe, dirty honeycombs, dirty coil. Lots of things. Lots of things it could be. Bulb off.
I get called a dirty coil pretty often.
Yeah. You're going to get flood back because what happens is that airflow, the fans going, the airflow going over the coil, you can't boil it off. You can't absorb the heat. So what happens, all of a sudden, it starts to flood back. Low charge will not cause flood back. It will cause high superheat. So that's a great question. On liquid injection, we use discharge temperature. Do you see any that is looking at discharge superheat? So no. So liquid injection is going to be, I should pull up those slides as well that I did earlier. Let me just see. So basically what liquid injection is on scrolls, and you can do it, you'll do it on old school compressors or even Bitzer ones when they were using mechanical devices, or Carlisle's when you were using mechanical devices. Would be just, it looks like a TX valve. That's what it looks like. And let me find one here. Yeah, liquid injection here. Let's take a look at this one right quick. So this is kind of the liquid injection for the Copeland scrolls. There's lots of different ones. When you put that goes right into the head. There's a little spring on there right here. Make sure that spring's on there. If it's not, it's going to trip off. I had a guy from down in Dominican, I think, maybe Turks and Caicos. He reached out to me and they were having problems. It was tripping off. And I asked him all the questions. He said, oh, it's all set up. But then, because his technician told him it was all set up, so he actually went out to the site and he pulled it out and there was no spring there and it was tripping off on a high head. It wasn't getting the cut. So that holds it in there nice and tight. And you have to put thermal paste in there as well. And so this one here, the ZF K4 is 193 Fahrenheit injection. 193 is what in Celsius? About 90 degrees Celsius in injection. But there's other ones that are 250, which is about 121 Celsius, 250 Fahrenheit, 120 Celsius, that will do the injection. Bitzer does discharge superheat. Copeland doesn't. So Copeland just wants you to go and check what's that discharge temperature. They want to keep it below a certain temperature. Does anybody know what that temperature should be? They want you to keep it below. Let's see in the chat. There it is, 225 Fahrenheit, 107 Celsius around. Because what's going on inside the compressor is another 50 to 75 degrees Fahrenheit, getting you up to that 300 degrees Fahrenheit, which is bad, which is around 150 Celsius, which is real bad for the oil. And the oil starts to lose lubrication, starts to break down, and it leads to a failure. Hopefully that answers your question. With compressor liquid injection, are compressors larger in cooling capacity and mass flow versus non-liquid injection? For example, when replacing older compressors in high temperatures, plus 45 degrees Celsius compressors and rack system. So when we take a look at low temp compressors, for an example, the largest one that scroll, we'll just do a scroll because I know this one off the top of my head. The largest scroll is a 54,000 BTU. We'll look it up. And it's called a ZF50 or maybe it's 54, 57K. So that means 50, I think it's 54,000 BTUs. So when we're talking in BTUs right at this point, and I'll tell you what it is in kilowatts in a few minutes. But you only actually get 18,000 BTUs when you're at very low temperatures. So as that's nominal conditions. So when you look at any compressor manufacturer model number and their displacements on there, or it's their capacity on there, that's at the nominal conditions. Okay. And when you take it out of that nominal condition, you start dropping the temperature, the capacity drops right off. Okay. So that's why you will see these bigger compressors in low temp applications to try to hit a higher capacity. I've noticed reefers carrier liquid injection using TXV. Yeah, for sure. So yeah, definitely on the Carlisles, you would definitely see. So it's a TXV. It kind of looks like this. So there's different brands. I think this one's I think they use Parker. Copeland use Parker for those. Yeah, that's it. That is it. Once again, follow me on the different social platforms. Shoot me an email or a message if you have questions. If you're looking to grow, if your company's looking for a training or you're looking to get a training for your company, I build and design these different courses that will definitely help take you guys to the next level. I know it. I see it. I'm helping a lot of people out there. I want to help you, and I will see you at the next Refrigeration Mentor training. Once again, let's get a conversation going. See you, everyone.